This is the flowchart for pH calculations. If you are given a problem, the first step is to figure out how many solutes in the solution. If there is only one solute in the solution, you will follow the left branch to figure out the answer. If there are two or more solutes in the solution, you will follow the right branch to figure out the answers. If there is only one solute in the solution, the next question you need to answer is the only solute an acid, a base, or a salt? If the only solute is an acid, you need to calculate the ratio between Ka and the initial concentration of the acid. If the ratio is larger than 10 to the third power, which is 1,000, then the equilibrium concentration of the hydronium ion is equal to the initial concentration of the acid. If the ratio between Ka and the initial concentration of the acid is less than 10 to the negative 3, then the equilibrium concentration of the hydronium ion is equal to the square root of Ka times the initial concentration of the acid. If the ratio between Ka and the initial concentration of the acid is in between these two numbers, you have to use the ice table to calculate the equilibrium concentration of the hydronium ion. If the only solute in the solution is a base, you have to calculate the ratio between Kb and the initial concentration of the base. If the ratio is larger than 10 to the third power, then the equilibrium concentration of the hydroxide is equal to the initial concentration of the base. If the ratio between Kb and the initial concentration of the base is less than 10 to the negative 3, then the equilibrium concentration of the hydroxide is equal to the square root of Kb times the initial concentration of the base. If the ratio between Kb and the initial concentration of the base is in between these two numbers, you have to use the ice table to calculate the concentration of the hydroxide. If the only solute in the solution is a salt, you have 4 different scenarios to consider. The first scenario is the salt is a product of a weak acid and a weak base reaction, such as ammonium carbonate. In this case, you do not need to worry because I will not put any kind of problem like this in the exams. Now let me explain what do I mean. Ammonium carbonate is a product of a weak acid and a weak base reaction. This is the chemical equation. A weak acid, which is carbonic acid, and a weak base, which is ammonium hydroxide. When an acid reacts with a base, it will produce a salt and water. The second kind of salt is a product of a strong acid and strong base reaction, such as sodium perchlorate. In this case, the solution is neutral. Let me put down the chemical equation. A strong acid, which is perchloric acid, and a strong base, which is sodium hydroxide. At this point, you may wonder, Dr. H, how do you know perchloric acid is strong acid, sodium hydroxide is a strong base? I strongly recommend you to memorize a list of strong acids and strong bases. If you don't know where to find them, you can watch my previous videos or my PowerPoint to find them. The third kind of salt is a product of a weak acid and strong base reaction, such as sodium fluoride. Sodium fluoride is a product of a weak acid and a strong base reaction. In this case, we will treat the sodium fluoride as a weak base. Then we will go here, finally end up here. Let me explain a little more why we can treat sodium fluoride as a weak base. Fluoride is a conjugate base of hydrofluoric acid. When we put sodium fluoride into water, it will dissociate to create fluoride. So we can treat fluoride as a weak base. Then we go here to find the equilibrium concentration of the hydroxide. The last scenario is the salt is a product of a strong acid and weak base reaction, such as ammonium chloride. Ammonium chloride is a product of a strong acid and weak base reaction. Ammonium chloride can be treated as a weak acid. We can go here. We will finally end up here to calculate the equilibrium concentration of the hydronium ion. Here is the explanation. Ammonium chloride will completely dissociate to produce ammonium ion and chloride ion. Ammonium ion will react with water to produce ammonia and hydronium ion. Ammonium ion is the conjugated acid of ammonia. If there are two or more solutes in the solution, the next question we need to answer is, are they going to react with each other? If the solutes do not react with each other, we will need to handle 3 different scenarios. The first scenario is the solutes are the conjugated acid-base pair. In this case, pH equal to pKa minus log the equilibrium concentration of the acid over the equilibrium concentration of the base. If the solution is a mixture between a strong acid and a weak acid, we just neglect the weak acid. Then we will go to number 1, which is here, to calculate the equilibrium concentration of the hydronium ion. If the solution is a mixture between a strong base and a weak base, in this case, we just neglect the weak base. Then we go to 4, which is here, to calculate the equilibrium concentration of the hydroxide. If the solutes in the solution do react with each other, you have to use stoichiometry to figure out what will be in the final solution and calculate how much of each chemical in the final solution after the reaction. Then you go back to the beginning of this chart, which is here. If you do everything correctly, you will end up with one of these 9 boxes.